गुड इवनिंग एवरीवन। एग्ज़ाम बहुत पास है और काफ़ी कम टाइम है हमारे पास, और मैं चाहता हूं कि सभी बच्चों के जो की कॉन्सेप्ट्स हैं वो फिज़िक्स के हम लोग मिल के मजबूत कर लें। तीनों सब्जेक्टों में टीचर्स आपको इंटरेक्ट करेंगे। अभी फिज़िक्स शुरू किया है, मैकेनिक्स मैकेनिक्स में लास्ट क्लास में मैंने काफ़ी चीज़ें आप लोगों को समझाई। एक दो चीज़ें और हैं, रिलेटिव वेलोसिटी, सूडो फोर्स, कोलिजन्स, रोटेशन। ये वो टॉपिक्स हैं जिनमें बच्चे बहुत वीक होते हैं, और इनको जब हम करेंगे, इनके कुछ क्वेश्चंस भी करेंगे और उसको एक्सप्लेन करते हुए बाकी टॉपिक्स भी कवर होंगे। तो चलिए शुरू करते हैं। रिलेटिव वेलोसिटी सबसे पहले क्विकली बता देता हूं, क्योंकि बड़ा इंपॉर्टेंट चैप्टर है और उसमें एक सिंपल लाइन का ये चैप्टर है। सब लोग अलर्ट रहेंगे और मैं बड़े इजी इजी वे में समझा के आपके दिमाग में बिल्कुल छाप दूंगा। You all will understand relative velocity properly, so please pay attention. And then pseudo force is based on that, and then other topics. We'll keep moving fast, and I'm just waiting for 1 more minute for students to join. I have a lot of students who have already joined. Okay, so now, and today we'll cover very important topics: collision, which involves everything of mechanics and rotation. So please be attentive. It will be beneficial for sure. All I want is participation. When I ask you a question, try to solve it then and there. When I ask you a concept, reply to that. And if you are attentive, it will definitely help you in your coming exam. Okay. Relative velocity is just one line chapter. Velocity of A as observed by B. When we write VAB, it means velocity of A as observed by B. Who is the observer here? B is the observer. So when I write VAB, it is understood. This is the convention, whether there is comma or not. It is understood that B is the observer. Please understand this. And this is written as VA vector minus VB vector. Now, when you have not specified, so motion is all relative. Am I at rest in this room right now? You may feel, any person sitting in the room will feel that I'm at rest. But actually, an alien who will see me from outside the planet, from Earth, will see that I am in motion because Earth is rotating. Okay, coming back to, huh. So motion is always relative. So I am at rest. A person sitting in the room, in this room, will feel I'm at rest. But an alien who's observing Earth from space will feel I am rotating with Earth and I'm in motion. So there is no absolute motion. The definition of motion is always with respect to an observer. So when we refer to velocities VA, VB, what do we mean by VA and VB? We mean the velocity relative to the ground. When we don't speak anything, relative to the ground. We are on the surface of the earth, so relative to the surface of the earth. Okay. So when nothing is written, it is understood. It is relative to earth, relative to earth. Okay. One more thing I want to highlight here. Velocity of A as observed by B can also be written as velocity of A with respect to another frame x minus velocity of B with respect to the same frame x. This frame, observer's frame, has to be same. So this one equation defines this chapter. Extremely important. Now let me show you few easy examples where you will learn. There's only one slide. Now next, if I tell you there is a man going in this direction with 100 meter per second. Okay, this is man, this is Ram, and there is another friend of him who's coming in opposite direction. His name is Sham, and he is traveling in opposite direction with 100 meter per second. Now you people need to visualize this, understand this very properly. This is Sham. We will do three things: velocity of Sham as observed by Ram, is what? Then we'll do velocity of Ram as observed by Sham. And there are two more things I want to do. Velocity of Sham as observed by Sham and velocity of Ram as observed by Ram. Now let's answer all these four and understand the physical meaning, how it is going to be. So when we say the observer is Ram, suppose Ram is the observer here. Okay. Here also Ram is the observer. Now, let's write down these velocities in the form of I cap, J cap with their direction. Let's assume this direction to be positive. I can say velocity of Ram relative to the ground. When nothing is said, it means relative to the ground. Okay. This is 100 meters per second I cap. Okay. What is velocity of Sham in vector form? Velocity of Sham with respect to ground if nothing is said. This is minus 100 meters per second I cap. Now get these four things. They may appear to be very simple. The reason I am doing it with so much clarity, ease, simplified, because I know it has use in pseudo force also, it has use later also. So every child should pay attention. Four simple things I want you to understand. So from here, we get velocity of Sham as observed by Ram will be velocity of Sham minus velocity of Ram. Let me put the values. This will be velocity of Sham is minus 100 I cap minus 100 I cap. This will become 200 I cap, but negative sign, minus sign, minus 200 I cap, minus 100 I cap, 200. Now, this is velocity of Sham as observed by Ram. What is velocity of Ram as observed by Ram? This will be VR minus VR, which will be 0. Now let's understand what is the physical meaning of this. Who is the observer here? Ram is the observer. What he is observing is we are going to now observe everything not from our information, our brains. We are going to observe everything from Ram's brains. We will get into Ram's brains. We'll sit on his chair and Ram is moving in this direction. So how is Ram feeling about himself? What is his velocity relative to himself? How is he feeling? What is his velocity as observed by Ram? Please write in the chat. What is the velocity of Ram as observed by Ram? 0. And if it is 0, what is he feeling? He is observing that he is not moving at all. So Ram feels he is not moving at all. He is at rest. We know, our brain knows that he is moving with 100 in this direction. But velocity of Ram as observed by Ram is 0. So he feels he is at rest. Now what is he feeling about Sham? Let's see. Now he is observing Sham from his brains. What is he feeling about him? That Sham is moving, velocity of Sham as observed by Ram is this, minus 200 I cap, which means he is feeling that Sham is moving towards him with in negative x direction with how much velocity? 200 meters per second. This is what he is feeling. Now, this is very important to visualize. Now, let's visualize the other situation. When observer is Sham, what is velocity of Sham as observed by Sham? 0. What is velocity of Ram as observed by Sham? VR minus Vs. This will be, VR will be 100 I cap. minus of minus 100 I cap, which will be 200 I cap plus 200 I cap. Okay. Now let's understand the physical meaning of this. Who is the observer now? Sham is the observer now. We are going to penetrate the brain of Sham and sit in his brains. So this is Sham. Sham is this body. Now, what is he observing about himself? What is his velocity as observed by himself? He feels I am at rest. He feels he's at rest. He's not moving at all. And what is he feeling about? What is he feeling about Ram? He feels Ram is moving in this direction. With how much velocity? 200 meters per second in this direction. Okay. We understood this simple thing. He feels about himself, he is at rest. He feels Ram is moving with 200 meter per second, and this is the observer Sham, how he is feeling, his brains. This is how Ram is feeling. And this 100 is what we are feeling. Okay. We got this clarity. Those of you who understood these 4 things, please give me a thumbs up, quick. Someone has a doubt, please feel free. Nagendra Prasad, you can ask your doubt. Unmute yourself and ask your doubt. Nagendra. Nagendra, you have raised your hand, and those who have understood it, give me a thumbs up. Now, I'll take it to a very interesting level where you will realize that once you have understood this, we'll come to pseudo force after this question. Just see the beauty of understanding this simple thing. This is x-axis, this is y-axis. A man is moving in this direction from here. He is 200 meters away and he is moving in this direction with 10 meters per second speed. There is another man who's also 200 meters away, but on y-axis, this is 200. And he is moving in this direction with a velocity 20 meters per second. Can you tell me who will reach? This is A, this is B. Who will reach the origin first? Both were equidistant. Who will reach the origin first? Quick. Just a quick answer. Write in the chat. I want to see how many of you are attentive. First question that I'm asking you is very easy. And I want to be sure that you are listening to me, participating in the lecture and attentive. So, okay, everyone knows B will reach the origin first. Okay. Now my question, real question for which this is designed is, so you realize that B will reach here first, A will be somewhere away on this line. They're moving in a straight line like this and like this. Now, my question here is, when will they come closest to each other? So it is not necessary that when B reaches here, at that moment A is almost 200, 10 second में 100 meter. It will be here. A will be here. If B dash, after 10 seconds, B will be here, A will be here. After some time, B double dash, B will be here, A will be here. Now, it may be possible that this distance might be the closest distance between them. It is not necessary that this will be the closest distance. So if I ask you what is the closest distance of closest approach? Distance of closest approach. Now it becomes a beautiful question between A and B. Between A and B. Some people might use maths, use maxima minima. Maths se bhi we can do this question. How will we do that? I can show you maths also. You assume after t time, this has traveled how much? 20t. After t time, it has traveled how much? 10t. So 10t, 20t. Now remaining distance, this and this. This is the distance as a function of time between them. This distance will be root of, this is 200. This distance will be root of 200 minus 20t square plus 100 minus 10t square. And now you have to do maxima minima. D, you can say this is X or S, whatever, some other symbol, so that you don't get confused while differentiating it. You have to find maxima minima as a function of time. You will get the value of time. Once you find the time, you substitute, you will get the distance also. Shortest distance between them. This is calculus. Instead of using calculus, I want to use relative velocity here. And I want to see how many of you can do that. I want to see your original thought process. Using relative velocity, you can easily do it. I want to see how many of you can do it. करके दिखाइए. क्वेश्चन फिर से मैं लिख देता हूं आपके लिए. You have x-axis, y-axis, 200 meter away, 200 meter away. This is A, this is B. He is traveling in this direction with 20 meter per second. He is traveling in this direction straight line along x-axis with 10 meter per second. And you have to tell me when will they come closest to each other. And you don't have to use calculus. I have already told you the method where you can use maths and solve it through calculus. I want you to solve it through relative velocity. I just want you to understand the power of relative velocity. So how will you do it? Can anyone tell me? Is there anyone? Just give me a thumbs up if you are capable of solving it on your own using relative velocity. Chaliye. I'll quickly make you understand how we utilize this. And this understanding the change of frame is very, very important for understanding pseudo force. Okay, I can't see any thumbs up. Everyone, please pay attention. Time being a limitation, we have to move fast. So I won't spend too much time in calculations, but understand the concept. See this. If we are observing the motion, we find B also moving, we find A also moving. But if we start observing the motion from the brain of B or A, if we assume A to be the observer, so what will A feel about himself? What will be the velocity of A as observed by A? It will be 0. So let's make one of them as observer. Suppose I make him the observer, A. This is the observer. So velocity of A as observed by A will be what? 0. He will feel he is not moving at all. So वो रेस्ट में आ गया यहाँ पे, ऐसे लग रहा है उसके ब्रेन से हमें ये फील हो रहा है. He is still. Now let's observe B from the brain of A. A is the observer. Velocity of B as observed by A will be, velocity of B is minus 20 j cap and velocity of A is I cap. This is the velocity of B as observed by A. Let's plot this. How's he feeling about his velocity? He is feeling, it has, observer A is feeling that B is moving with minus 20 j cap. So 20 meter per second in this direction and minus 10 I cap, 10 meter per second in this direction. And this will be the resultant velocity. The resultant velocity will be along this line. So now just understand this. How is A feeling now? A is the observer. We went into his brain. We are observing everything from his brain. A feels he's at rest. So he is fixed and B is moving like this along this line. Now, can you tell me what is the closest distance between these two? Will this perpendicular distance be the closest distance between these two or not? And now rest is geometry. See this. This angle is theta. Tan theta will be, this is 20, this is 10. So tan theta will be 10 by 20. Tan theta will be half. Once you know tan theta, you will know sin theta, cos theta. Once you know this, you will know this is 90 minus theta. If this is 90 minus theta, this is also 90 minus theta. This is theta. Now, using geometry, you will be able to find this perpendicular distance AX. AX. X is this point. And that will be the shortest distance between them. Now, actually, B is not going to go along this line. Actually, B is always moving like this and passing like this. Actually, A is moving like this as per our brains, as we are observing it. But if we get into the brain of A, we make A the observer, then A is feeling he is at rest. He is not moving at all. B is going like this. And then it becomes just a coordinate geometry, trigonometry problem to find this perpendicular distance. And this is how you should utilize. So even the questions that you have, many questions, you have rain falling down and just a 1 minute break. So now, so we understood relative velocity. So in case of raindrops which are falling down with say constant speed, suppose they say it is with 10 meters per second, raindrops are falling. Now raindrops, obviously they are doing free fall. They cannot be having constant velocity, but assuming that the moisture is there and raindrops have attained a terminal velocity and they are falling down with 10 meter per second, air friction is there. So constant velocity, and a man is on the ground and he is running, and man is running with some velocity in horizontal direction. Suppose this is the velocity of man. Now, there are questions where they ask you at what angle he should hold the umbrella and all those things. Again, it is velocity of man as observed by man. This is velocity of raindrops. This is velocity of man. Suppose this is again 10 meter per second. Now, velocity of man as observed by the man will be 0. He will feel he is not moving at all. He is at rest. Velocity of raindrops as observed by the man will become, velocity of rain as observed by man will become minus 10 j cap minus 10 I cap. You can see this. I'm skipping some basic terms, steps. Now, if you plot this velocity properly, you will realize man is feeling that the raindrops have 10 meter per second velocity here and 10 meter per second in this direction, and resultant velocity will be like this, and the raindrops will appear to him to be falling in that angle, and you will find out this angle will be 45 degrees. So the man must hold his umbrella at an angle 45 degrees this way. Now, these are the kind of questions. Again, all these questions are based on relative velocity, and I've tried to explain to you. Now we shift to pseudo force, then collisions, and then rotation. Now, what is the meaning of pseudo force? This is again a very confusing topic for many students. Please try to understand this. If you have a block kept on a frictionless table, this table has no friction, and hence this block is a 10 kg block, and hence there is, because there is no horizontal force, there is no frictional force, there is no push or pull, this block is at rest and its acceleration is 0. Now, if I am on the ground, I feel this. But if I'm moving in a car which has an acceleration, suppose I'm moving in a car which is accelerating, this frame is accelerating with 20 meter per second square in this direction. If you observe this block from this frame, you will find this block has acceleration in opposite direction. And how much is the acceleration you will feel? Is 20 meter per second square. It has an acceleration. Now, you can see there is no force acting on this 10 kg block. There is no physical force. It is kept on a horizontal frictionless surface, and yet it has acceleration. How is that possible? So Newton's laws are not applicable here. They are being violated. There is no force, and still the person sitting inside the car is feeling that this block is moving. So the moment you are in an accelerated frame, acceleration hai. So these frames are called non-inertial frames. So whenever you will observe motion from a non-inertial frame, you cannot apply Newton's laws. You cannot say net force is equal to mass into acceleration. You have to do a modification. D. Lambert, a scientist, gave that modification. He said, if you make a small change and you apply a pseudo force, you apply an imaginary force on this body, then you can apply Newton's laws of motion. And how much should that force be? That force should be mass of the body being observed, mass of the body into acceleration of the frame, observer, frame of the observer, and opposite in direction. This should be the pseudo force. जो आप लगाएंगे P pseudo should be this. ये आप लगा दीजिए, लगा देते हैं. So mass of the body being observed is 10. We will apply a pseudo force in this direction. We will say, because we are observing the motion from an accelerated frame, non-inertial frame. If you are observing from a non-inertial frame, a frame which has acceleration, you have to apply a pseudo force, and that pseudo force will be equal to 10 into mass into acceleration of the frame, 20. एंड माइनस के साथ ऑपोजिट डायरेक्शन में. सो आप अपोजिट डायरेक्शन अगर आपने ऑलरेडी टेकन केयर, देन यू डोंट नीड टू पुट माइनस साइन हियर. यू विल से वेक्टर फॉर्म में यू हैव टू पुट माइनस साइन. डायरेक्शन इफ यू हैव ऑलरेडी इनकॉर्पोरेटेड ऑपोजिट डायरेक्शन में, तो मैग्नीट्यूड ऑफ pseudo force should be this much. Now this much pseudo force is acting, and now if you are writing the Newton's laws of motion, you will say net force acting is this pseudo force, and this pseudo force 10 into 20 should be equal to mass into acceleration. 10 into acceleration, and acceleration you observe is 20, which is correct. Now,
Can you explain this one again?
Yeah, I'll explain. So when do we apply pseudo force? What is the implication of it? When do we use it? If you have not understood, please pay attention. Again, I'll explain. Very important. So this is a block kept on a horizontal frictionless surface. This surface has zero friction, no friction. It is having some mass m. I am sitting on the ground and observing this. Please tell me, what is my velocity? Reply. The same child. I am sitting at rest on the ground and observing this table which is at rest relative to the ground. This block is kept on the table, no friction, no force. Now tell me, what is my velocity? Zero. What is my acceleration if I am sitting at rest on the ground? बच्चे आप ही रिप्लाई करिए, जिसने पूछा प्लीज एक्सप्लेन इट अगेन. Zero. So this is such frames where acceleration is zero. It could have been moving with 10 meter per second. I could sit in a car which is moving with 10 meter per second towards right. But my acceleration is zero. If acceleration is zero, what will be the acceleration of this block relative to me? This is me, Praveen, and this is block. So what is the acceleration of block as observed by Praveen? बताइए. That will be acceleration of block as observed by Praveen will be equal to acceleration of block minus acceleration of Praveen. And that is zero. because acceleration of Praveen is also 0, acceleration of block is also 0, 0. Now, such frames where acceleration is 0, they are called inertial frames. Inertial frames. Now, in this frame, you can see net horizontal force acting on this body is what? What is the net force in horizontal direction that is acting? mg is acting vertically downwards, normal reaction, contact force is acting vertically upwards. It is exerting a normal reaction on the table. What is the force acting on this body in horizontal direction? इस डायरेक्शन में कोई फोर्स लग रही है क्या इस ब्लॉक पे? बताइए. There is zero force acting on it. If there is no force acting on it, net force is 0. Net force is equal to mass into acceleration of this block, and acceleration is also 0. यहां से आ गया acceleration. Acceleration is 0. So Newton's laws are applicable in inertial frames. If you will apply some force, it will have net force is equal to ma. Correct होगा. अब खेल प्रॉब्लम कहां पे आती है? प्रॉब्लम आती है नॉन इनर्शियल फ्रेम में. सो सपोज नाउ आई ऑब्जर्व इट फ्रॉम अ फ्रेम विच इज मूविंग. आई एम सिटिंग इनसाइड अ कार and my car is moving with some acceleration a naught. This is Praveen. Now can you tell me what is the acceleration of block as observed by me? बताइए.
minus a naught.
Yes. Acceleration of
Minus
block as observed by Praveen now will be acceleration of block, which is 0, minus acceleration of Praveen, and that is minus a naught. Yes. We are seeing, Praveen is seeing this observer who's sitting inside the car is accelerating. He's observing some acceleration for this block, and he's feeling this block has an acceleration in this direction and it is a naught. But can you give any explanation to Praveen? Why is it having acceleration? Because there is no horizontal force acting on this block. So Newton's laws fail in non-inertial frames. So in my frame, inside this car, when I am observing any other body, because my car is accelerated, my frame is non-inertial frame. Non-inertial frame. And if my frame is non-inertial frame, उस frame में always ये गड़बड़ होगी, and you will find discrepancy. There is no force acting on this body, and yet I am feeling that this block has an acceleration a naught in this direction. How is that possible? Without there being any external force, the block is having acceleration as observed by me. That is a discrepancy. Newton's laws are failing in a non-inertial frame. To correct that, gate खोल दो. To correct this, खोल दो इसको. To correct this, D.L. Lambert, a scientist, he gave the concept of pseudo force, that if we modify, if we tweak, if we just add an imaginary force on our own, then Newton's laws जैसे पहले लग रहे थे वैसे ही लगेंगे in this non-inertial frame, in this observer frame. So वो modification is called pseudo force. ये इस observer के frame में. और pseudo force कितनी लगानी है? Mass of the body being observed into acceleration of the frame opposite direction में. तो ये pseudo force लगानी है m into acceleration of the observer और डायरेक्शन होगी ऑपोजिट. ये एज शोन इन द फिगर. ये फोर्स लगा दीजिए आप एक इमेजिनरी. ये लगाई. अब आप इस फ्रेम में भी न्यूटन्स लॉज लगा सकते हैं, जबकि ये फ्रेम नॉन इनर्शियल है, एक्सेलरेटेड है. आप क्या लिखेंगे? ये फोर्स लग रही है, नेट फोर्स लेफ्ट साइड पे एम ए नॉट शुड बी इक्वल टू मास इनटू एक्सेलरेशन ऑफ दिस बॉडी. एंड यू कैन सी एक्सेलरेशन इतनी दिख रही है, ए नॉट करेक्ट दिख रही है लेफ्ट साइड पे. सो दिस इज कॉल्ड सूडो फोर्स कॉन्सेप्ट. नाउ अब मैं इसकी इंप्लीकेशन, इसकी एप्लीकेशन, इसकी कहां यूज है और ये क्यों, व्हाई आर वी बीइंग टॉट दिस कॉन्सेप्ट, यू विल अंडरस्टैंड दिस.
सर पर ब्लॉक तो रेस्ट में है ना.
बेटा रेस्ट में अर्थ के फ्रेम में है. इट इज एट रेस्ट इन अर्थ फ्रेम, नॉट इन द कार्स फ्रेम.
हाँ.
When you are observing it from a moving car, it is not at rest. It is having an acceleration in left direction. Have you ever seen trees going back when you are moving in a car?
Yes. हाँ.
So your concept of relative velocity is very weak. Please get this. The moment you will start understanding that, don't keep thinking from your own brain. You have to go and think from the observer's frame. When we are talking about relative velocity, when we are observing this block from this car, now you have to think from the perspective of this person who's sitting inside the car. And that person is feeling that this block has an acceleration a naught towards left.
सर वो नहीं बोल रहा था मैं बोल रहा था कि लाइक हम स्यूडो फोर्स इसलिए अप्लाई करते हैं क्योंकि हम इनर्शियल फ्रेम से वो फाइंड आउट करें कि उसका एक्सेलरेशन एक्चुअल में क्या है.
नहीं नहीं,
इस
आपको किसी ने गलत, someone has taught you wrong. Please understand this. Pseudo force is only applied when you observe any motion from an accelerated frame, which is non-inertial frame. Are you getting it? Did you
Yes.
get it? Please get this clear. It is being recorded also. All of you can get a copy of it. Go to internet, go to this thing, chat, GPT, this thing, AI. 1 second mein you will get to know what is pseudo force. And you need to learn the right concept. Pseudo force is an imaginary force which is applied to a body when that body is being observed from a non-inertial frame, accelerated frame. Are you getting it? Got it? बच्चे क्लियर हुआ? ठीक है, अब आगे चलते हैं. 1-2 क्वेश्चंस करके दिखाता हूं आपको, उसकी एप्लीकेशन बताता हूं. नाउ सो लेट्स सी द एप्लीकेशन ऑफ दिस. Many children are confused about a body is moving in a circle of radius r and it is tied to a string. This is a body of mass m and it is moving in a horizontal circle. It is on a table, horizontal table, frictionless table. And this body is moving with a constant speed u naught in the circle. So all of you know, if a body will move in a circle of radius r with constant speed, it will have an acceleration. Will it? Yes or no? It is moving with constant speed in a circle of radius r in horizontal plane. Can you tell me, does it have any acceleration or not?
Yes, sir.
Yes.
It has an acceleration. How much is the acceleration? And in which direction?
Omega times r.
V square upon r towards the center. U naught square by r is the centripetal acceleration. Now, this is the acceleration. If the body will be here, the body will have an acceleration towards the center. And what will be the acceleration? U naught square by r, V square by r, towards the center. Anywhere, the body will always have an acceleration towards the center, and that acceleration is called centripetal acceleration. This is a part of your circular motion chapter. I expect this much everyone knows. Now, right now here I'm focusing on the pseudo force concept. Now, if I ask you, this body is tied to a string AB, this is A, this is B. Find the tension in this string. Find the tension in this string. So what will you do? For circular motion, your important directions are radial direction and tangential direction. So you will mark all the forces in radial and tangential direction. So I am taking a direction which is radial, and let's assume the tension to be T. We'll mark 2 arrows pointing towards each other. This tension in the string is pulling the body towards the center, and the tension in the string is pulling the center towards this. But we are making a free body diagram of this body. Now, tell me, if I observe this body from the ground, there is only one force acting in radial direction, tangential direction, we don't have any force. What is the equation I should write towards radial direction? ये direction में क्या इक्वेशन लिखूं मैं? आई एम अज्यूमिंग दिस डायरेक्शन टू बी पॉजिटिव, इसको पॉजिटिव ले लीजिए, और ये टेंशन हमने अज्यूम की है टी। तो क्या इक्वेशन लिखें हम? नेट फोर्स टुवर्ड्स द सेंटर टी शुड बी इक्वल टू मास इनटू एक्सेलरेशन. This is the tension. How many of you understood this? Give me a thumbs up. Now I'll come to the pseudo force part. And there is no pseudo force acting on it because we are observing the motion from the ground. Now, how many of you got it? Okay. Okay. Now let's understand, if we observe this body from the ground, this is the equation. There is no pseudo force. There was no pseudo force. Pseudo force. Even the body is moving in circular motion because we observed the observer was at ground, Earth's frame. Now I am going to change the frame of the observer. अब मैंने एक ऐसा इमेजिनरी फ्रेम लिया, मैंने कहा यार हम इस बॉडी को एक ऐसे फ्रेम में बैठ के ऑब्जर्व करेंगे जो इस बॉडी के साथ ही साथ चल रहा है. अब मेरा आपसे क्वेश्चन है, कैन यू टेल मी इस फ्रेम की वेलोसिटी क्या है? इज इट मूविंग इन अ सर्कल और नॉट? This frame is attached to the body. Now tell me, is the frame also moving with constant speed u naught in radius r circle? Yes or no?
Yes, sir.
Is the frame having an acceleration?
Sir.
What is the acceleration of the frame? What is the acceleration of the frame?
Yes, sir.
U naught square by R.
U naught square by r, correct. In which direction? किस डायरेक्शन में है? एक्सेलरेशन ऑफ द फ्रेम किस डायरेक्शन में है? टुवर्ड्स द सेंटर. इस डायरेक्शन में है. जब भी whenever a body is moving in a circle of radius r, it has a centripetal acceleration. Therefore frame also has an acceleration towards the center. So this is towards the center, towards the center. Now if I tell you, we will observe this block, red block body from this frame, the frame which is attached to it. The frame is also moving with the body in circle of radius r. Now tell me, is our frame of observer is inertial or non-inertial? The new frame. Our frame is having an acceleration, yes or no? Please reply.
Yes, sir.
Our frame has an acceleration, therefore it is a non-inertial frame. If it is a non-inertial frame, will we apply pseudo force on this body or not if we are observing this body from this frame?
Here is a
Will,
pseudo force, sir.
The
we will
frame
apply.
attached to the body is a non-inertial because it is accelerating. Hence, pseudo force must be introduced.
Pardon? Repeat again, बच्चे.
The frame attached to the body is non-inertial.
Non-inertial. Therefore, we should apply a pseudo force on the frame, and the pseudo force should be how much? It should be mass of the body into acceleration of the frame. Acceleration of the frame is u naught square by r, and we should apply this pseudo force in which direction?
Towards
Opposite to the acceleration of the frame, in this direction. This is the pseudo force we will apply. And one more question. If I am observing this body from this frame, what is the acceleration of this body now with respect to this frame?
0.
What is the acceleration of this body now as observed from this frame? 0. Because the frame is moving with the same acceleration as the body. So acceleration of the body as observed by the frame will be acceleration of body minus acceleration of frame. Both have same acceleration, so acceleration will be 0. So the body will appear to be at rest in this frame. So we will write, now the equation will be, there are two forces. One is tension, other is pseudo force, and we'll write the equation tension minus pseudo force
Sir, we
Should,
have to write the acceleration of the body is rotating frame is 0.
yeah, mass into acceleration of the body will be 0 in the frame, this frame. Now, again, we are getting the correct answer. So you can observe a body from inertial frame also. You can observe the body from a non-inertial frame also. In both the cases, you will get the correct answer. But if you are ever observing the body from a non-inertial frame, you have to be careful about applying pseudo force. And that pseudo force will be mass of the body into acceleration of the frame opposite direction. That's it. So this is what I wanted to highlight. Now, many people, the moment they see a circular motion, they apply a pseudo force outwards. Please don't do that. You have to be very clear. When do you have to apply pseudo force? Whenever you are observing it from a frame which is accelerating, then only you apply pseudo force, otherwise not. Now, okay, now we are coming to a beautiful question based on this concept. I want you people to realize how important pseudo force is. See this. It will become a little tough for many of you, but it is important. If you are paying attention and you have got this clarity, you will find it easy. See this. This is a body which has a spherical cavity, and this spherical cavity radius is big R. There is a point mass. There is a point mass, and this point mass slides down. There is no friction here. There is no friction here. No friction anywhere. This is small m, this is big M. The wedge is also free to move. So it slides down, it comes to the lowest position. Will the wedge also move or not? Just reply. Wedge is not fixed. Can you tell me, will the wedge move or not?
Sir, 1 minute.
The wedge is also free to move, slide on this
Here
table,
the wedge
and the
moves.
table is frictionless. Table is frictionless. Every surface is frictionless. So when it will be falling down and will reach the lowest point, the wedge would be also moving. So let's assume the wedge has some velocity towards left. The point mass has reached at the bottom and is having a velocity v1. The wedge is also moving towards left and has a velocity v2. Now, if I ask you, now we are doing mechanics, linear momentum question. Can you tell me, will the linear momentum of the system be conserved or not? Quick reply. Linear
Yes, sir.
momentum of system.
Yes, sir.
Center of mass system stays in the same horizontal position.
That's a good answer. Center of mass will remain at the same position in horizontal direction. I could have asked you, when it reaches the lowest position, how much has the wedge moved? If I ask you the position of the center of mass of the wedge after it has reached the lowest position, then you need to use the center of mass concept. Because there is no external force acting on the system, center of mass of the whole system in horizontal direction should not shift. So to find the position, you would have used that. Right now, I am asking you, can I conserve linear momentum of the system in horizontal direction? Yes or no?
Yes, sir.
Linear
Yes, sir.
momentum of the system is conserved only the horizontal direction because there is no external horizontal force acting.
My question was very specific. In horizontal direction, can I conserve linear momentum? Yes or no is the answer. Choose one.
Can you repeat again the question?
My question is, if I assume small point mass and the big M both as one system, big M and small m as one system, and release this from rest, it falls down. Can I assume that the whole system will the momentum of this whole system in horizontal direction remain conserved? This is my question. Will the momentum of small m and big M be conserved in horizontal direction? Yes or no?
Yes,
Quick.
sir.
There is no external force acting in horizontal direction on the whole system. When they are moving, they are exerting some force on each other. When the block will reach here, they will exert some force on each other like this. But that force is internal force. There is no external force acting on them from outside in horizontal direction. Therefore, linear momentum of the system will be conserved. Now, this is small m, this is big M. What was the initial linear momentum of the system? In horizontal direction, both were at rest. So linear momentum of the whole system for point mass small m was also zero, for big M also zero initially. Initial linear momentum in horizontal direction. Initial linear momentum was zero.
Sir,
Should be
initial velocity or final velocity will be zero, right?
Bache, initial linear momentum of the whole system is initial velocity. Everything was at rest. So it had no horizontal velocity. It had no horizontal velocity initially. So initially, linear momentum was zero for small m, zero for big M. Initial linear momentum was zero for horizontal direction I'm talking about.
For the
Now,
system, linear momentum is a conservation only
conservation of linear momentum we are doing. Please repeat.
horizontal direction, and not the vertical direction.
I am not talking about vertical direction right now. I'm only focusing on horizontal direction. When the body small m has reached the lowest position, this body has only horizontal velocity. It doesn't have any vertical velocity. Can anyone tell me how can I be sure that it has zero vertical velocity at this instant? Quick. Constraint. This wedge, the point in contact, this point, has zero vertical velocity. It can only shift horizontally. The ball, when it reaches the lowest point, is in contact with this point. Therefore, vertical direction constraint, they are in contact with each other. Therefore, it cannot have a vertical velocity at this instant when it is at the lowest position. It can only have a horizontal velocity. Therefore, I am conserving linear momentum in horizontal direction. For small m, it will be mv1 and this direction to be positive. So opposite direction will be negative. For big M, it will be minus mv2. How many of you understood this? That the total linear momentum, this is the final linear momentum in horizontal direction. And this is the initial linear momentum. Both will be same, conserved. So this, how many of you understood? How many of you understood this conservation of linear momentum? Give me a thumbs up. Okay. Quite a few. Good, good, good. Now, next. This is a very beautiful problem. There are few more things that I want you to understand. Just see this. Linear momentum conservation, we have got one equation. Now my question is, will energy be conserved? Yes or no? Reply. Energy, mechanical energy of the system. Energy will be conserved, yes or no?
Yes, sir. It will be conserved.
Yes, sir.
Because there is no dissipative force, there is no friction force. So energy is not being lost. What is the loss in gravitational potential energy by small m? How much gravitational potential energy it lost? It is a point mass. Quick. Loss in gravitational potential energy, it reached how much height it has fallen down? This much height. So mgr, loss in gravitational potential energy by small m is this. Big M has not lost any height. It has not come down or gone up anything. So total loss in gravitational potential energy should be equal to kinetic energy of the whole system. This should be equal to half mv1 square plus half big M v2 square. Is it correct or not? How many of you understood this? Give me a thumbs up. Those who understood this energy conservation equation, give me a thumbs up. Now we have two unknowns, two equations, V1 and V2. Find out the value of V1 from the first equation, put it in V2, you will get V1 and V2. You will be able to find the velocities. Okay, I can see a lot of thumbs ups. Now, alert. I will be doing collisions today. Now, after this, I want everyone to be attentive. There are a lot of misconceptions people have, and I will give you full clarity. Just wait and watch. Now, so we did this. Now, there is something beautiful I wanted to discuss here, which will challenge your brain. Those of you who have understood till here, now my question to you is something different than this. We did this, we found V1, V2. Now we are fully aware of V1 and V2. Now my question to all of you is, now this becomes a JEE advanced question. My question is, can you tell me what is the contact force between them right now? What is the contact force between the wedge and the ball? ये contact force कितनी है? Will it be equal to small mg, yes or no? First you tell me this.
Yes, sir.
Huh?
Yes, sir. It is the small mg.
No, it will not be equal to mg. So first big
Sir,
mistake is
acceleration will also be there, right? Centripetal.
yes. So there is acceleration. This child who answered. Now let's do this answer in two parts, two stages. First stage is I will simplify it for you and make it very easy for you. The very easy part is, suppose I tell you this wedge is fixed. It is not moving at all. Suppose. And this point mass fell down, reached the lowest point, attained some velocity V1, and V2 is 0. Suppose I tell you this. In that case, what will be the equation of normal reaction that you will write for vertical motion of small m? If you can understand that, then you will understand the next level of difficulty. Let's write down that equation. See this. If this wedge is fixed, it is not moving. This body is doing circular motion like this, pure circular motion. If it is doing circular motion, you know radial direction is important. In radial direction, this is one force, normal reaction. Mg is another force. Second force is mg, small mg, acting on the ball. These are the only two forces. Now, can you tell me when it is moving with velocity v1, what is the acceleration of this body when it is moving in a circle?
mv1 square by r.
Acceleration is v1 square by r.
Acceleration.
Acceleration is, wow, I'm impressed. What's your name?
Nandan.
Nandan, I'm impressed. Now just be attentive. Acceleration is towards the center. I am going to now use upward direction to be positive. Net force vertically upwards is n minus a small mg for the ball, small ball. This is the net force towards the center, should be equal to mass into acceleration. Acceleration is v1 square by r. Is this correct or not?
Correct, sir.
Yes, sir.
Correct. So all of you understood, n will not be equal to mg, n will be equal to mg plus mv1 square by r. This will be the normal reaction in the first case, case 1, when I am assuming this wedge to be fixed. Now we come to IIT JEE advanced level, beautiful level. The next level is when now we go back to our previous situation. Our previous situation is both are moving. This ball has a velocity v1, the block has a velocity v2. Both are happening. Now who will tell me? I will be royally impressed if you tell me now. So now both are happening. Will the normal reaction be this or different? First answer. Will it be or different? Just answer.
Different.
Will the normal reaction in this case, when both are moving, will it be this or different from this? पहले तो यही बता दो, different होगा तब
Different from this, sir.
Who
No
answered
change.
this? It'll be different.
Instead of V1, you have to use the relative velocity concept. So it will be V21.
Nandan. Is it Nandan who said this?
No.
Who answered this?
It's Kanishk, sir.
Kanishk. Impressive. If you have this clarity, you're doing good. Let's move. Just see this. Everyone should realize this. This motion of this ball will not remain. Let me use some other color. The motion of this ball will not remain circular if we are observing this ball from the ground. Why? Because when it is falling, if this wedge was fixed, then it was a circular motion like this. But if the wedge itself is moving, so the ball is going not in a proper circular motion at all. How do we now write the equation? To write the equation, we will shift our frame. We will shift ourselves to this wedge. यहीं पे जाके बैठ जाते हैं, यहां से ऑब्जर्व करते हैं. If we will observe this ball, small m, from this frame, what is the velocity of the frame? What is the velocity of this frame? Big M. Velocity is v2. What will be the velocity of small m as observed from this frame? Because in this frame, if we go and sit here, we will then see it doing a circular motion with respect to this frame. Otherwise, from the ground, the motion becomes very complicated. So from the ground, you cannot write this equation. Now, what we need to do is, the relative velocity will be velocity of small m, velocity of small m as observed by big M, because we have gone and sat here. हम यहां जाके बैठ गए on big M. So we are observing the motion relative to big M. Then we are seeing a circular motion path. And then we need to use this velocity. This velocity will be velocity of small m minus velocity of big M. And that will be V1 minus V2, which will be V1 plus V2. Now, so the velocity now you will take will be this, and your equation now will become n. Free body diagram is again having n is acting upwards, mg is acting downwards, n minus mg is equal to, what will be the change? Mass into v. Velocity will be what? V1 plus V2 whole square by r. Now this is little tough to understand, but those of you who understood this, please give me a thumbs up. I'll be extremely happy to see few thumbs up also. Okay, 3, 5, 8, 10. Oh wow, quite a few. Good. So this whole funda is worth investing your time in, and it was a tough question for sure, intelligent question. Now we move little ahead. Okay, so I made you do free body, momentum, question. So through questions, we'll understand the concepts also, and we will understand physics also, chapters also. So just be attentive. Now we are jumping to collisions. These are the topics which every year children tell me that we find it difficult to understand them. So I want to give full clarity to all of you on this. Collisions. Can anyone tell me work, definition of work done? How do you define work?
Force into
Force
Displacement.
Yes,
displacement of
force
point.
dot displacement. Now my question is, this displacement is the displacement of the center of mass of the body, or this displacement is the displacement of the point of application of force? Which?
Point of application of force.
Yes, it is not the displacement of the center of mass of the body. Everyone must know the right definition. So please, everyone note it down. See the beauty. You will understand what I'm talking about. Displacement of the point of, mute him. There are some children, there is someone who's trying to disturb the class for no reason, and I'm sure it is someone who's not very sincere about studies and usko usme maza aa raha hai, fun. The beauty of learning physics, getting prepared for the exam, bhai ko usse kuch lena dena nahi hai. Anyways, just be attentive. Now this concept is very important to understand. If I tell you, because this will be used, this will be, suppose I tell you a man is walking on the ground. There is a runner. Let me ask you very conceptual and exam type questions. Objective. This is a runner. and he is running in this direction. He was initially at rest and he started accelerating. My first question to you is, the ground is applying a friction force on him in which direction? He starts running towards east. The ground is
Opposite
applying a
direction.
friction force
West
West.
on
direction.
in which
Towards west.
direction?
West
wait,
Towards
wait.
east. East. Towards
Towards
east.
east. Towards
So all those who are saying
East.
west are wrong. So the ground is exerting a force on him towards east only. He is trying to push the ground with his feet behind, and the ground will exert a force, friction force will act towards east. Now, some children who just cram that friction opposes motion, तो उनको लगता है कि man is running towards east, friction should act towards west. That is wrong, and I am sure many of you have that conceptual clarity, and those who don't, get that clarity. Search करो, खुद दिमाग लगाओ, books पढ़ो. Anyways, I have made you clear. Friction is acting towards right. Can you tell me, when a runner is running, is the static friction is acting or kinetic friction is acting?
Static friction.
static.
Static. Yes. Can you tell me what is the of this man ran for here 100-meter race? He ran a 100-meter race. And when at the end of the race, so there was a friction force acting on him, and that friction force, his velocity, suppose, was 200 meter per second at this instant when he reached the finishing line. What is the kinetic energy initially? Quick.
0.
Zero.
What is the final kinetic energy?
Half mv square.
Half mv square. Did friction do some work on him or not?
No.
What is the work done by friction force on him? Friction
Zero.
force was, say, 10 Newton, suppose. And displacement is 100 meters. Did friction force do any work? Yes or no?
Yes.
No, sir. No, sir. Zero.
Who's
Yes,
saying
sir. Yes,
zero?
sir.
Who's saying zero?
Pradyun.
Good, correct. Impressed. Very good. Your funda is clear. Friction force is static friction force between his feet and ground, and that friction force will not do any work. And now I have a question to you. Then ये जो change in kinetic energy हुआ, ये किसने, कहां से आई ये एनर्जी? अगर फ्रिक्शन ने कोई वर्क नहीं किया, ये जो काइनेटिक एनर्जी गेन की उसने, ये कहां से आई?
Velocity.
हाँ, वेलोसिटी तो शुरू में 0 थी, फाइनली कुछ हो गई, तो ही गेन
Acceleration of the man.
हाँ
Acceleration की वजह से वो
बेटा, एक्सेलरेशन तो एक डेफिनेशन है हवाई कि भाई चेंज इन वेलोसिटी को एक्सेलरेशन बोलते हैं, बट भाई कोई इंजन नहीं है, कुछ नहीं है, तो ये वेलोसिटी जो काइनेटिक एनर्जी चेंज हुई है, ये वर्क एनर्जी थ्योरम के हिसाब से वेयर डिड दिस एनर्जी अपीयर फ्रॉम, कहां से आई ये एनर्जी जो चेंज इन काइनेटिक एनर्जी गेन की है, तो वो एनर्जी आई कहां से? ये बड़े, दीज कैन बी वेरी इंटेलिजेंट ऑब्जेक्टिव कॉन्सेप्चुअल क्वेश्चंस फॉर कॉम्पिटिटिव एग्जाम्स. वेयर डिड दिस काइनेटिक एनर्जी कम फ्रॉम?
Due to change in displacement.
Not the right answer.
Sir, can you repeat question again?
Question is, a 100-meter race happened. A runner was at rest initially here, and he started running. The ground was exerting a friction force on him. That friction force was static. His feet were not slipping. तो स्लिपिंग नहीं हो रही है, तो स्टैटिक फ्रिक्शन फोर्स लग रही थी. दैट फ्रिक्शन फोर्स वाज 10 न्यूटन, आई टोल्ड यू, इन दिस डायरेक्शन. नाउ and he moved 100 meters. What was the work done by friction? First question is work done by this friction force. Is it work done? First question is this. Second question is change in kinetic energy happened. Where did that kinetic energy come from? कहां से आई वो energy? Now, these are very conceptual and beautiful questions that I am asking you. So everyone must understand what is being discussed. What is the work done by friction? Quickly.
0, sir.
Work done by friction is 0. And let me explain that to you. आप
Friction,
जब दौड़ते हैं,
but it does not supply energy.
नहीं, please try to understand this. When I am running on the ground, मैं जब run करते हुए 1 feet is in the air, 1 feet is on the ground, and this is how I am running. Please pay attention, everyone. How do we run? This is how we are running on the ground. Now, the feet that is touching the ground, friction force is acting on that feet. And I'm going to mark it there. Suppose this feet is in touch with the ground, friction force is acting on it. This feet is in air. ये air में. So what is the displacement of this point where this friction is acting? Is there any slipping happening?
No.
What is the velocity of this point which is on the ground in touch with my feet? ये वाला feet. ये ground
0,
का point
0.
है, ये feet है. Ground के point की velocity is 0. So feet की velocity is also 0. If there is no displacement happening for this force, there will be no work done by this force. Force dot displacement. And displacement has to be the displacement of the point of application of force. Just understand this. Now, if the other leg which is in air, it is getting displaced, और ये अब यहां जाएगी और नीचे जमीन पे रखेंगे हम ऐसे यहां. अब जब उसे जमीन पे रखूंगा ये वाली लेग एयर में चली जाएगी. So whenever you are putting any foot of yours on the ground, that point of application of that friction force is not moving, it is at rest, and therefore friction force is acting there. Displacement happening is 0 for that point of application of force. So work done by friction force is 0. This is an intricate concept. Many of you might not have understood it. You have to go home and sit on it and get this clear. So while running, if there is no slipping happening between my feet and the ground, and I'm running, so static friction is acting, and static friction force does no work. Even the car tire, when the car is moving on the ground, on the road, the friction force is rolling friction or static friction, unless the car tires are skidding. So till then, the work done by the static friction force is 0. So work done is 0. Okay. Second question was, is there a change in kinetic energy? Yes. Initially, velocity was 0. Finally, velocity is 200 meter per second. So obviously, there is a change in kinetic energy, and that is half mv square, mass of the man, into 200 square. But where did this energy come from? Friction didn't do any work on the man. Where did this energy come from?
Did
Because
it
of
come
the
from
force
like
applied by the man.
This energy is the energy provided by our muscles. Work was done by our muscles. In case of a car, that energy is being provided by the engine, which is burning the energy in the form of combustion of fuel. यहाँ पे तो ये जो रनिंग है ये आपकी बॉडी को पतला क्यों करती है? स्लिम होने के लिए, इसलिए आपको जॉग करना चाहिए, इसलिए आपको रन करना चाहिए, क्योंकि वो आपकी मस्कुलर एनर्जी अपीयर हुई है इन द फॉर्म ऑफ काइनेटिक एनर्जी. Get this clear. Now, okay, this was something very important I want to highlight, that this is the displacement of the point of application of force, not the center of mass of the body. Now, next question. Next concept. Collisions, quickly. Everyone attentive? There are 3 types of collisions: elastic, inelastic, and perfectly Inelastic. Okay. Elastic can also be written as perfectly elastic or just elastic. Now, let's understand how do you identify what will happen in which kind of collision? Okay. What is the pehchan? Everyone pays attention. There is a wall and wall is rigid and it is not going to there will be no deformation in the wall. Wall is very rigid, perfect, ideal wall. And there is a ball which is going to go and hit it. And it is just about to hit it. Pay attention, try to understand. The whole collision chapter, in a summary, in next 10 minutes, I'll make you understand if you are paying attention. So everyone's attention must be there. Okay. Now, suppose this is a rubber ball, just to make you more clear. This rubber ball is suppose going with some velocity, which is say u0. Now, this rubber ball will go further and will start compressing against the wall. So wall will not deform at all because it is ideal, and the ball will go and compress itself and it will keep compressing and will reach a stage where the ball is like this. Ball has reached and keeps compressing. Now, center of mass is here. Now, it will keep pushing against the wall and keep compressing till its velocity becomes 0. After this velocity becomes 0, the ball starts bouncing back. The ball starts coming back. The whole spring kind of behavior will push it back and it will start gaining its velocity again. And suppose after the collision, the ball returns back with the same velocity u0, suppose. Such collisions are called elastic collisions or perfectly elastic collisions. My question, in any collision of any kind, is there a temporary deformation of the bodies colliding? Yes or no?
Yes.
There is temporary deformation. Is there kinetic energy, going to be converted to some other form during the collision?
Potential energy.
This is elastic potential energy, or you just say some other form. Kinetic energy got converted to some other form during the collision. If that kinetic energy is gained back completely, then that collision is called perfectly elastic collision. So perfectly elastic, kinetic energy initial should be equal to kinetic energy final of the whole system. Now, in case of perfectly elastic collision, the ball will regain and reach its own original shape. The colliding bodies regain their original shape. There is no permanent deformation. There is temporary deformation, but there is no permanent deformation. Now, this is how we understand perfectly elastic or elastic collision. Elastic collision, the bodies will get deformed during the collision. The energy may be converted from one form to another during the collision, but after collision, the bodies regain their original shape and there is no loss of kinetic energy. This is called perfectly elastic collision. Everyone should note it down. Second, inelastic collision and perfectly inelastic collision, there is a permanent deformation. The ball will not get into its original shape. There may be some deformation that remains here. थोड़ा सा पिचक गई है बॉल, ये लो, और फिर वापस आई है. So the velocity will not remain the same. It will change. So for this inelastic collision, how will you recognize it? There is permanent deformation. There is permanent deformation. Third, perfectly inelastic. The velocity of separation is zero. Velocity of separation. ये जाके वॉल से अगर चिपक जाए तो what is the velocity of separation is zero. No, this is like the simplest thing I can explain these three collisions forms. Now there are certain catches now, fine things which you need to catch and learn. Now my question is, kinetic energy here initially before collision and kinetic energy here after collision remains conserved. Is it true for perfectly elastic? Yes. Will kinetic energy be conserved here? Kinetic energy before collision? Will it be conserved?
No,
No,
sir.
it will
It
be
will not
greater
be
than the
conserved.
final.
Yes, it will be lesser than the initial kinetic energy, and some kinetic energy has been converted to either heat or deformation or any kind of noise, sound energy that got, जब एक कार और ट्रक टकराएंगे तो एनर्जी साउंड की भी होती है, तो वो काइनेटिक एनर्जी से किसी और फॉर्म में कन्वर्ट होके लॉस हो गया. काइनेटिक एनर्जी विल नॉट बी कंजर्व, नॉट कंजर्व हियर. क्विक, yes or no? Not
Yes, sir.
conserved, not conserved. Only in this case kinetic energy of the system will be conserved. Okay. Now total mechanical energy. If mass is not getting converted to energy or energy is not getting converted to mass, will the total mechanical energy
Yes,
it
mechanical
will be
energy will
conserved
be.
in all the cases? Yeah. So energy from one form, say kinetic energy is getting converted to sound energy, deformation energy, any other form of energy, heat energy during the collision, but total energy सबको मिला के will remain constant. So total mechanical energy is conserved in all the three. Please note it down. Total, this is second point. Total mechanical energy is conserved here also, here also, here also. Now, if there are two bodies which are colliding, this ball is going to collide with another ball and they are kept on a horizontal frictionless surface. This ball is coming in this direction with some velocity u1, this is going in this direction with some velocity u2, and this has m1, this has m2. Can I say the total, and this is frictionless, can I say the linear momentum of the system will be conserved in all the three cases of collision? Linear momentum.
Yes, sir.
Yes. If I assume both of them as one system, when they will collide, they will exert a force on each other. They will exert a force on each other. That force will be, this is force of collision, F, I am saying it. This is an internal force. If I am assuming both of them as one system, is there anyone from outside who's pushing them in a horizontal direction? No. So the external force is zero. So whenever two bodies collide, the force that they exert on each other is an internal force. There is no external force acting. If there is no external force acting, we will conserve the linear momentum of. So this third point, linear momentum of the system is conserved in all the three. Linear momentum of the system is conserved in all the three, because the force that they exert on each other during collision, that is an internal force. If external force acting on the system is zero, linear momentum will be conserved. Okay, we got it here. Now, there is one more thing you need to understand. One thing I want to ask you, can you tell me, is this force a constant or a variable? This force is constant force, or does it vary during the collision? Tell me.
During the collision.
During the collision, is this force constant or is it going to vary?
Very.
It is a variable force. Initially, just before collision, force acting between them is zero. Then they start compressing each other against each other. So that force keeps on increasing. Then they reach a maximum closeness level. And at that instant, maximum compression is there like a spring. And then at that instant, there is maximum force. And then they start separating and the force starts decreasing. So this force of collision, first thing about it is, this force is a variable force. It's not a constant force. Not a constant force. Second, that is why they always write it as Ft. Force is a function of time. They will say, if the duration of collision is 0 to delta t, I mean, delta t is the duration of collision. Can you tell me, is delta t for a collision, is it very small or not?
Small.
Duration of a collision is very small or not?
Small.
Yes. And that's why collisions and collision forces, the forces that act during the collision, they are impulsive forces. They are very large in magnitude because the duration of collision is very small and the sudden change in momentum is happening. The change in momentum is happening over a very small time period, and that's why those change in momentum upon time taken is defined as force. Those forces are very large in magnitude. So please note down this. Duration of collision is tending to zero. It tends to zero, and therefore this force, which is variable, though it will change, but it has very large magnitude. Okay, we understood it till here. Now, one last thing I want you people to understand, and that is E, coefficient of restitution. If you understand this last thing, after that, I'll make you do problems of IIT level, CET level, every level with full clarity. There will be no confusion on any collision question if you have understood the coefficient of restitution equation. Okay, let's pay attention. Identical balls right now, and it is very easy to write. E is equal to this is written as coefficient of restitution is equal to minus V2 minus V1 upon U2 minus U1. Everyone please note it down. And note down these two. V2, V1 and U2, U1 are the velocities. V2, V1, U2, U1. They are the velocities of center of mass, not of the center of mass. They are the velocities of the points of collision. They are not the velocities of the center of mass. They are the velocities of the points of collision. Right now, these balls are identical. You will feel that the center of mass is moving with the same velocity as this point and this point. But when you will have rotation, a rod colliding with a body, you will realize what I'm trying to say here. So please note it down. These V2, V1 are the velocities after the collision. U2, U1 are the velocities before the collision, but they are not the velocity of the center of mass. They are the velocities of the points of collision. Ye please note it down. And points of collision. Okay. For this simple thing, we will do it quickly. Let's do a simple problem. Simple problem where we don't have to worry too much. Okay. 5 kg ball moving with 10 meter per second. Another 5 kg ball moving with 20 meter per second. Identical balls on a horizontal frictionless surface, head-on collision, there is no oblique collision, and they come and collide with each other and find their velocities after collision. This is the question. Okay. I will assume right direction to be positive x direction. Okay. Now, this velocity is minus 20. This is plus 10 I cap. Whatever way you have to write. Okay. Now, this is x-axis. How do we solve such problems quickly? Let's see. One is, and this is a perfectly elastic collision. For perfectly elastic collision, E is 1. For perfectly inelastic collision, E is 0. And for in between, in inelastic collision, E lies between 0 and 1. Okay. I am right now in this case telling you E is 1, perfectly elastic collision. How will we solve this problem? First is, we'll write down the equation of conservation of linear momentum. So let me assume after collision, these bodies have some velocity. This has V2, this has V1 after collision. And U1 is this, and U2 is this. Initially, they had these velocities. Finally, I am assuming both are going towards the right. I do not need to bother about which one will go left and which one will go right. I don't know. We'll just assume it to be towards right. If any of them has to go towards left, the value will come out to be negative on its own. You don't have to worry about it. Now let me write down the conservation of linear momentum, because when they will exert a force on each other, that force will be an internal force. External force in horizontal direction on the whole system is 0. What is the initial linear momentum of the whole system? For 5 kg, initial linear momentum is 5 into initial velocity, 10 I cap. Okay. Direction is important. Momentum is a vector. For this body, minus 20 kg meter per second. Units you have to write on your own. Initial momentum of the whole system is this before collision. After collision, the linear momentum will be 5v1. Right direction is positive, plus 5v2. Okay. This is the equation of conservation of, we have conserved conservation of linear momentum. I am doing a very basic question so that everyone is on the same page. And the next question will be an interesting question. Now, this is linear momentum conservation. Second equation, for perfectly elastic, I can write energy equation. Energy conservation, kinetic energy. Kinetic energy before collision, kinetic energy after collision will remain the same. I can write these two equations and I will have two unknowns, two equations, V1, V2. And in that equation also I'll have kinetic energy may V1, V2, but that will be a quadratic equation. Suppose we want to solve it fast, we instead of writing the energy equation, we prefer the coefficient of restitution equation, which will be 1 will be equal to minus V2 minus V1, V2 minus V1, velocity of separation after collision, upon U2. What was the initial velocity of this body? Initial velocity of this body is minus 20 I cap minus. What is the initial velocity of this body? 10 I cap. Khatna. This is E. Now we will use these two equations, 1 and 2, and we will avoid kinetic energy will be conserved, but we are not writing that equation because that is a quadratic equation and the calculation can be lengthier, which will take some more time. So we will prefer linear equation. So we'll use this and this 1 and 2. Now I have a question here. Is this coefficient of restitution, how is it defined? How is it derived, this equation? How was this coefficient of restitution equation defined? Is it based on energy conservation and momentum and derived from there, or is it something else? It is an empirical formula, experimental lab में करके जो formula derive हुआ है, ये वो formula है. Empirical formula. Please everyone note it down. It is an empirical formula. Now, we will always prefer E equation, E, coefficient of restitution, and this equation. Okay, we solved it. If suppose I give you a question, I'll give you a complicated question later. Right now, I want you to this table. So in this table, every one of you should note down that E is equal to minus relative velocity of separation, relative velocity after collision, या फिर velocity of separation. Whatever you write, velocity of separation upon velocity of approach. Velocity of approach. Basically, it's relative velocity after collision and relative velocity before collision. And because they both will come out to be opposite to each other, so there'll be a negative sign. उस sign को minus लगा देते हैं जिससे वो positive हो जाए, or you just write down modulus of this. In any case, you will get the same answer. Now, define U and E, and E is 0 here, 1 here, and it is lying between 0 and 1 here. Okay. These are the things you need to understand, the concept, the theory. Now let's do questions. And let's do interesting questions. Okay. On collision. Suppose I tell you, this is a ball and this is going to hit a rod, which is lying on a horizontal plane, and it will hit it at the other end. Mass M, length L, and this is small m. So try to understand, we are seeing the top view. The rod is lying on a horizontal table like this. The ball comes and hits it, ऐसे, and it will start rotating and translating both. So there'll be both the motions. And you will, now we are trying to learn how to do these kind of questions. So can anyone tell me what will be the velocity? ML small m, and this is coming with u naught, and it is going to come and collide at the other end, near the end, and with this velocity after collision. You have to tell me what will be that. When they say describe the motion of the rod, they mean velocity of center of mass of the rod, angular velocity about the center of mass of the rod, and this point mass will be going with some velocity. It may bounce back, it may go ahead. We do not know, but you have to tell me what is the velocity of this point mass also after collision. Let me assume that to be v dash. So we have three unknowns. We have to find out these three unknowns. Now just try to do it. All of you give it a try. Collisions for अब collision, and we have shifted our domain from collisions of point objects to collision and rotational motion, both mixed. We are doing a question so that you get some clarity. Just try to do it. I want to see how many of you are good at it. Try to solve this. Write down 3 questions and tell me how will you solve it. Is there any child who feels he can do it? Or should I start doing it? Chaliye, let me solve it for you and make you understand the interesting concepts that are involved here. Okay, now we are coming to rotation also. Now, if this rod is lying on a horizontal frictionless table, this will start moving also टकराने के बाद after collision, and it will start rotating also. It will start moving like this. This point mass will also be either going this way or this way, but it will not have a velocity in this direction. Every point has to have an explanation, and the explanation for that is when they are colliding with each other, if I magnify this and I draw this and this like this, so you will realize the contact force that is acting between them is acting in the common along the common normal. If this force which is acting along the common normal, it cannot have any component in this direction. Therefore, the momentum will change only in this direction. So there will be no velocity change in this direction. So its velocity in this direction was zero initially, will remain zero finally. So that is why everything you have to think. Now, coming back to the question. Can I conserve linear momentum of the rod and point mass? I assume both of them as one system. Can I conserve the linear momentum of the system? Yes or no? Quick. Whatever force they will exert on each
Yes,
other,
sir.
that will be internal force. We can conserve linear momentum?
Yes, sir.
Okay. What will be the equation? Quick. Initial linear momentum of the point mass was m1 u1. For the rod, initial momentum was big M into 0. It was at rest. So this was the total linear momentum. I am assuming right direction to be positive. This is positive x. After collision, linear momentum of the point mass is going to be small m into v dash. And for the rod, it is going to be big M into VCM. How many of you understood this equation is correct? Give me a thumbs up. Quick. We just conserved linear momentum of the whole system, rod plus point mass, and we wrote the equation. Perfect. Second equation is going to be conservation of angular momentum. Alert. Conservation of angular momentum of the whole system. About which point? If external force acting is 0, external torque is also 0. If external torque acting about any point is 0, you can conserve angular momentum about that point. Which point you want to choose? You can choose any point in space. I am right now choosing a point which is coinciding with the center of mass of this, and it is in space. It is not moving with the rod. This point is an imaginary point. Please note it down. Why am I insisting on this? You will understand. Imaginary point coinciding with center of mass of rod, but in space. It is in space. It is not space. It is not attached to the rod. There is a reason. Center of mass of the rod is going to accelerate during the collision. And if we sit on the center of mass, it is an accelerated frame. We want to be at a point which is at rest. उसके about हम angular momentum conserve कर रहे हैं, तो इसलिए मैंने imaginary point coinciding with the center of mass of the rod in space लिया है. This point will not move. Rod will start moving. Okay. Now, about this point C, we will be conserving angular momentum of the whole system. Can anyone tell me, you people know the definition of angular momentum of a point mass moving with a velocity u naught about any point? Can you tell me about this point, what will be the angular momentum? For a point mass, it is R cross P. P is the linear momentum. So R cross MV. And in simpler terms, angular momentum. In simpler terms, this is also equal to M into V into R perpendicular. How many of you have heard about this thing? Otherwise, I'll teach you this. Angular momentum of a point mass. How many of you are aware of this? MV into perpendicular distance? Okay, quite a few. Good. Now, so I'll quickly write angular momentum of this point mass before collision is mu naught into L by 2 about C. We are conserving angular momentum about this point. Okay. And is it clockwise or anti-clockwise? It is moving like this. So it is clockwise. Okay. Clockwise positive. We have chosen clockwise to be positive. ये आप mention कर लीजिए, anti-clockwise will be negative. Okay. Now, for the rod, initial angular momentum is 0. The rod was not translating nor rotating. So there is no angular momentum before collision. Now, after collision, angular momentum of the point mass will be mv dash into perpendicular distance L by 2. For the point mass after collision. And for the rod, it will be ml square by 12 into omega cm. If by any chance any one of you is not clear about angular momentum topic, I have a recorded lecture on YouTube. You go to PACE channel, PACE IT and Medical, and see that lecture. You will get full clarity on angular momentum of a point mass, angular momentum of a rigid body. Do not miss that. I've explained it very clearly. And angular momentum about a point, angular momentum about an axis, both I've explained. If you will understand that, you will understand torque also. And I have made a small video on all these 2-3 topics. Angular momentum, torque, about a point, about an axis, all. So please utilize that video and please see that video on PACE IT and Medical channel. You'll find out Praveen Tyagi. Physics के फंडे या कुछ ऐसा नाम है उसके. और नेहा मैम यू कैन शेयर, आप ये शेयर करा दीजिए ग्रुप में. सो मेक पीपल share those videos of angular momentum, torque definitions to the students so that they can easily get that. I have very clearly in detail explained that concept. Please see those videos if by any chance you don't know this. Now, coming to third equation. So this is conservation of linear momentum. This is conservation of angular momentum. And now third equation we'll write as coefficient of restitution. How do I write coefficient of restitution equation? Can you rub this? ये वाला part rub कर दो. How do I write? इससे होगा. Good. So if I want to write E equation, coefficient of restitution, that is what I wanted all of you to learn. So please pay attention. Everyone has to be attentive. E. It is a perfectly elastic collision. E1 should be equal to minus. Now please understand, you will not use, what will you use? Get this right. We will go to the points of collision. The points of collision are these. So there is one point here, which is point mass. I'm naming it as 1. And there is this point, other point is the point of collision of the rod, which is colliding. I'm naming that 2. We will use velocity of 1 and 2, point 1 and 2 in coefficient of restitution, not center of mass velocities. Now, please be attentive. V2 minus V1 upon U2 minus U1. What is V2? Velocity of 2 can be found by superimposition theorem. Again, please ensure that superimposition theorem lecture also I have taken, superimposition of velocities. If there is a rigid body, it has both. अगर ये एक rod है and it is translating with center of mass velocity, so every point will have VCM. If this rod is just rotating and with angular velocity omega cm, every point will have r omega cm velocity, r omega. R will be that point ka distance from the axis of rotation. If both the things are happening, you will superimpose both the motions. You will have vector form mein V cm plus omega cross r, and add these two in vector form, you will get the net velocity. This is called principle of superimposition. I have taken a video lecture on that also. Please go to the YouTube channel, see that. I am going to use that. Velocity of this will be, due to translation VCM, it will have a velocity here VCM. Okay. Due to pure translation. Due to rotation, it is rotating about this point with omega cm. So it will be L by 2 omega cm due to rotation in the same direction. And total velocity of point 2 will be this. So you will write down this velocity. This velocity of point 2 will be VCM plus L by 2 omega cm. This is the velocity of point 2 minus velocity of point 1 is V dash after collision upon U2. What was the velocity of this point before collision? 0 minus. What was the velocity of this point before collision? U0. Now, this is your third equation. This is E, coefficient of restitution. This is conservation of linear momentum. This is conservation of angular momentum. These are three very important concepts for mechanics. Angular momentum, linear momentum, coefficient of restitution. If you people, any child who has understood all these three equations correct, give me a thumbs up. That person is on the right track for sure. Okay. Those of you, Pradyum, Ninad, who else has understood all these three? These are, the moment you understand this much, you are prepared for IIT JEE Advanced also, but you need to have full clarity on these. Very good. Many of you, quite a few. Good. Good, good, good. Now, children, there are more intricacies which I want you people to understand, but I want you to pay the price for it. And the price is hard work. I request, before I proceed with more interesting, conceptual, and cover the full portion, I request you to work hard at home. For that, all you have to do is get access to the PACE IIT and Medical YouTube channel. Go there, find Physics Ke Funday or something, my lectures. There, angular momentum, torque, collisions also. 2-3 lectures are there. Please watch them quickly, fast forward karke, get the concept. When you have got the concept, then when we will solve the questions and superimposition theorem also, sorry, you will find your life very easy. And we will be saving a lot of time. So I request, please go home and do this before my next class. Maybe your next lecture will be for other subject, but I do not want any slack at this time. So please go and check those things. Thank you. Thank you, everyone. Thanks. Rod mass collision. Yeah. I can do more questions. Yeah. Anyone else? You want to say something? You have any doubts, questions? Please feel free to ask. Anyone else? Should I do more questions? Should I?
Your lessons are present in YouTube, huh?
Yeah, these lectures are there where I have
I
explained
like
angular momentum,
YouTube
torque.
lectures, huh?
Few lectures are there about these concepts of rotation and all, which I took, and they are stored there properly. Okay?
Okay, thank you.
Nice talking to you, all of you, and teaching you, and
Sir,
thank you
can
so
you do
much.
some more questions?
Yeah, I can do few more questions. Okay, ready? I have a rod hanging from the wall, and it is hinged here. There is a point mass which is coming and going to hit it at this level with a velocity u0. Mass is m0. This is a rigid rod and it is hinged here, mass m, length L. This distance is L by 3. Now, if I ask you describe the motion of this point mass, a perfectly elastic collision, suppose. Okay, I forgot to tell you one very important thing I just recalled. So when we were learning these, perfectly inelastic collision, please don't assume that the bodies stick together. That's a wrong way of learning that. So initially, when we are teaching this concept to the children, initially we say they stick together. No, they don't stick together. I'll make you understand what I'm trying to say. This concept has to be very clear. So perfectly in IIT JEE Advanced, this question came once. So there is a ball which will hit an inclined plane, and this ball is coming like this. Say it is dropped from here, it hits it like this. Yeah. Now, they say the collision is perfectly inelastic. They said that. And find the velocity of the ball after collision. The wedge is fixed. This angle is given, theta something, m mass, h height, whatever. And they say the collision is perfectly inelastic. Now, if the collision is perfectly inelastic, majority of the children have crammed that the bodies stick together. So most of the children did it wrong by assuming that it got stuck here. It stuck here. No. What happens is, just before hitting, suppose it gained some velocity, and that velocity was root 2 gh. So when a body falls from rest and falls down a height h, it has a velocity root 2 gh downwards. Okay. Now, just before collision. Now this velocity will have two components. One component is this is 90 minus theta, and this is theta. This is theta. So root 2 gh cos theta in this direction, cos 90 minus, this is 90 minus theta. So root 2 gh cos 90 minus theta will be root 2 gh sin theta. Root 2 gh sin theta here, and root 2 gh in this direction, cos theta. This will be the velocity just before collision. Now, when the collision will happen, they will exert a force perpendicular to each other, normal direction, this direction, in this direction. So, inelastic collision says that the velocity of separation will become zero. Velocity of this ball and velocity of the wedge. Wedge is fixed, suppose. Suppose wedge is fixed. So this point's velocity is what? Zero. What should be the velocity of this ball after collision in this direction? What should be the velocity? Bataiye. Zero, if it is perfectly inelastic collision. So for inelastic collision, the velocities along the common normal will become same. And because the wedge has zero velocity, so the ball will also have zero velocity in this direction. But it doesn't say the same thing for this direction. So for this direction, the ball will continue with this velocity. So this velocity is not zero. Please understand this. For perfectly inelastic collision, they don't stick together. If the two bodies stick together, that is perfectly inelastic collision. That is true, always. But if they don't stick together, they can slide tangentially, and still it can be a perfectly inelastic collision if their velocities along the common normal become same. So the velocity along the common normal should be same. This should be same. Because the wedge is fixed, this velocity has to be zero. So the ball also has velocity zero. After collision, it doesn't bounce back. It will slide down the plane with this velocity, and that was the answer, and it came in IIT. So this thing I wanted to make you clear about this table that we drew, where we were learning about inelastic and perfectly inelastic, that please always note it down. So the condition is not, this was the condition. Velocity of separation should be zero along the common normal. So velocity along
Sir, it is always zero.
separation along the common normal. See, in this case, just now I gave you an example. The velocity of the ball, though it is perfectly inelastic collision, still the ball has a velocity parallel to the surface, common surface. It doesn't have a velocity perpendicular. For perpendicular direction, separation velocity will become zero. Separation is velocity along velocity along common normal should be same दोनों बॉडीज के लिए, और रिलेटिव वेलोसिटी शुड बी 0. बट किस डायरेक्शन के लिए? along the common normal, not along the tangential direction. So this ball, despite having a perfectly inelastic collision, still had a velocity after collision in this direction, and that, because it was frictionless, that velocity remained unchanged. So it was root 2g sine theta. Okay, how many of you understood what I'm trying to say here? So for perfectly inelastic collision, sticking together is not the condition. The velocity along the common normal should be same, but that is what is the catch. They can slide tangentially and still be perfectly inelastic. हाँ.
सर समटाइम्स जेडब्ल्यू में ऐसा भी क्वेश्चन आता है, जैसे बुलेट वुड को ऐसा पियर्स करता है, तो उसका
हाँ, वो सब कर लेते हैं, अभी कर लेते हैं, पहले यही बता दो. वो तो बहुत ही आसान है, बुलेट पियर्सिंग. अभी आप पहले मुझे ये बताइए, इस क्वेश्चन को करिए और एक बुलेट पियर्सिंग का भी कर लेते हैं अभी. जस्ट डू दिस. Try to do this question. This collision is perfectly elastic. Or let's take it inelastic. Easy हो जाएगा आपके लिए. We shouldn't keep doing one type of questions only. So the collision is perfectly inelastic. Inelastic. Or suppose it is a bullet, it gets embedded in this. ऐसे ही ले लो, अभी जो आपने बोला यहाँ पे चिपक गई रॉड से. अब आप बताइए, what is, how do you define the motion after collision? So obviously you all know, just pay attention. If it is perfectly inelastic, and second case we'll take elastic. Both we will do. Now, after collision, if this sticks to it and gets embedded in it, suppose perfectly inelastic collision we are taking, if it gets embedded in this rod somehow, rod is wooden, bullet is metallic, gets embedded here, how do you define the motion? There will be angular velocity of this combined thing here, pure angular velocity. How will we do that? Can I conserve linear momentum of rod plus point mass? Yes or no?
yes.
No, we can't. We can't conserve linear momentum. Reason? Who will explain? The moment this will collide with it, there will be a force, impulsive force between these two at the time of collision. Yes or no? And if that force is very large, there'll be a sudden jerk in the rod and there'll be a normal reaction. There will be a horizontal hinge will exert some force on it in horizontal direction. Now that force is an external force. So on the rod, the hinge is exerting an external force, and that too very large force, because it is happening all of a sudden with a jerk. Now, because there is an external horizontal force acting, we cannot conserve linear momentum. So linear momentum ruled out, gone. Can I conserve angular momentum? Quick. दूसरा ACD on करो. Can I conserve angular momentum?
Yes,
Yes. About any point or about some fixed point?
sir, hinge.
No, not about every point. We can conserve angular momentum only about this point. Reason: any force that will be exerted by this hinge will pass through this, whether it is in vertical direction or horizontal direction, they will pass through this hinge. And these are the external forces. What will be the torque about this point of these forces? 0. If I choose any other point, the torque about that point will be there by these forces. And so I cannot choose any other point except the hinge. So hinge, I will conserve angular momentum about the hinge only. There is mg, but that mg also has zero torque about this point. So hinge is a special point here, and therefore we will conserve angular momentum about the hinge. Just before collision, what is the angular momentum? Quick. For the point mass. mu naught into, what is this distance? Perpendicular distance. कितना है? 2L/3. And this torque is, this angular momentum has a anti-clockwise direction. Yes, like this. This is moving in this direction. No, anti-clockwise positive. Anti-clockwise positive. We'll mention that. No. For the rod, initially angular momentum was 0. It was at rest. Now, after collision, both have become one rigid body, if it is the case. Moment of inertia of the rod about this point is how much? ml square by 3 plus, for this point mass about this, how much is the moment of inertia? m 2L/3 whole square, mr square. This is the total moment of inertia. If the bullet has gotten embedded in the rod, in that case, they become one rigid body. We find the moment of inertia, I omega. Khatam. This is the equation. Conservation of angular momentum about the hinge. Conservation of angular. Bachcho, please understand this one thing. People whose concepts are strong, who have understood what is linear momentum, what is angular momentum, what is energy conservation, what is work done by a force, 10-15 concepts total. They will find whole mechanics very easy. If those concepts are weak and you have not understood that, for you this will be rocket science. Otherwise it will be a very easy one-line equation. You got the angular velocity omega. You got the answer for the first case. Now, for the second case, if it is a elastic collision or perfectly elastic collision, what will we do? Now the bullet is not going to get embedded. Now it will be like this. It will have some velocity after collision. In this direction, I am assuming it to be V dash. I don't know. It may go back. So V dash will come out to be negative. No issues. Now, I will write down angular momentum conservation. Linear momentum again fails for this case also. No linear momentum conservation because there is hinge. Here, there is external force. This external force is applying a torque about the center of mass or any. But for this point, we can conserve angular momentum. Net torque about this point is 0. I will conserve angular momentum for elastic case. mu naught into 2L/3. Initial angular momentum of the point mass plus rod is 0. Rod was at rest. After collision, point mass is moving with V dash. So mv dash into 2L/3. For the point mass, this is the angular momentum anti-clockwise after collision. And for the rod, it will be ml square by 3 into omega dash. In that case, it is omega dash for the rod. This is the angular momentum conservation equation. And the other equation, you have two unknowns, V dash, omega dash. These are the two unknowns, this one and this one. We have got one equation based on conservation of angular momentum. The other will be E. Coefficient of restitution is 1 is equal to. Let's name these points, points of collision. I have told you very clearly, we will name them as this point of the rod is 1 and this body we will call 2. Now, V2 minus V1 or V1 minus V2, whichever you write first, same thing you have to write below first. So V1, what is the velocity of the rod? This point. This will be 2L by 3 into omega dash. V1 will be 2L by 3 into omega dash. This is the velocity of this point of the rod after collision. V1 minus V2. V2 is V dash upon U2 was 0. U1 was 0 minus U2 was U0. Khatam. These are two equations, two unknowns. This we got from coefficient of restitution. This we got from conservation of angular momentum. Children, the reason I'm not doing too many questions today, because I want you to first go home and see those videos and get this funda clear about angular momentum. Otherwise, for you, this will be a rocket science equation. How many of you understood everything that I taught today? Give me a thumbs up, honestly.